Scatter a handful of fine sand across a metal plate. It sits there in a formless mess, the way sand does. Now draw a violin bow along the plate's edge so it rings with a clear tone, and in an instant the sand flees. It leaps, it scatters, and then it settles all at once into a precise geometric figure. Clean curves, perfect symmetry, a pattern that looks designed. You did not arrange it. The sound did. Change the tone, and the sand jumps into a completely different figure. What you are looking at is something we are usually told is invisible. You are looking at the shape of a sound. Let's slow down what just happened. The plate is not simply shaking up and down as one solid piece. When it rings at the right frequency, it flexes into a standing wave, a pattern of motion that stays put while the plate vibrates through it. Some regions of the plate heave up and down violently, thousands of times a second. And threaded between them are special lines where the plate does not move at all. Perfectly still, while everything around them is a blur of motion. Those quiet lines are the key to the whole thing. Now think about a single grain of sand. Wherever it lands on a heaving region, it gets kicked, bounced, and rattled until it skitters away. But if it happens to land on one of those still lines, there is nothing to throw it off. It just sits. So grain by grain, the sand is evicted from everywhere that moves and collects along everywhere that doesn't. The figure that appears is not a picture of the vibration. It is a map of the stillness, the exact places the wave holds its breath. Those lines have a name, the nodal lines. The sand is only making them visible. So the pattern is really the plate's own hidden anatomy, drawn in sand. And here is where it gets beautiful. Raise the pitch of the tone, and the plate answers by flexing into a finer standing wave, one with more of those still lines, packed more tightly together. A low note gives you a simple figure with a few bold curves. A higher note shatters it into something intricate and dense. Every frequency has its own signature shape, and you can watch the sand rebuild the figure, live, as the pitch climbs, sound, quite literally, drawing itself. Look closely at what changes as we sweep the frequency upward. Each pattern holds, perfectly stable, and then snaps to the next as the plate locks onto a new way to vibrate. It doesn't slide smoothly. It reorganizes. That is the plate jumping from one natural mode to another, and it is the single most important clue to what is really going on underneath. Because these figures are not arbitrary. Each one is a solution to an equation, the wave equation on the plate, and the clean patterns correspond to its special standing wave solutions, called modes or eigenmodes. Each mode is a pair of whole numbers counting how many ways the wave folds across the plate, one count for each direction. Whole numbers, because you can only fit a whole number of half waves onto a fixed plate. The same reason a guitar string plays discrete notes and not a continuous smear. The universe here only allows certain shapes, and the sand is showing you which ones. That is also why the sand only snaps into a figure at certain pitches. Sweep the tone slowly, and most of the time the sand stays a restless, formless mess. The plate is being pushed at a frequency it doesn't want. But hit one of its resonant frequencies, one of the pitches that matches a real mode, and the whole plate suddenly rings with that pattern, and the sand crystallizes. Resonance is the plate saying yes. Everything in between is it saying no. People have been mesmerized by this for over 2 centuries. In 1787, a German physicist named Ernst Chladni published these figures and toured Europe performing them by hand, bowing plate after plate to conjure patterns out of sand. A physics demonstration that drew crowds like a magic show. He performed for Napoleon, who was so struck that he funded a prize for anyone who could explain the mathematics. It took the mathematician Sophie Germain years of work to lay the foundations, and the full theory of vibrating plates occupied physicists well into the modern era. These humble sand figures sit at the very birth of the science of acoustics. And what Chladni found by hand, we can now state as a simple rule. Higher modes vibrate at higher frequencies, and higher frequencies carve more nodal lines. Pitch and pattern are locked together. Tell me the frequency, and I can tell you roughly how intricate the figure will be, and tell me the figure, and I can read back the note. The sound and its shape are 2 views of the same thing. And because the plate is a 2-dimensional surface, it doesn't have just one figure or even a few. It has an entire alphabet of them, a distinct pattern for every mode it can hold, and the higher you climb, the more elaborate they become. Simple crosses and circles give way to lattices, then stars, then flowers, then forms with no name at all. A single square of metal turns out to be a whole silent orchestra, and each pitch you feed it draws a different score. That is the quiet astonishment of it. All of this structure was latent in a blank plate the entire time, and sound is simply the hand that turns the pages. Now here is why this is far more than a parlor trick. The exact same physics governs almost everything that rings. It is why a violin body has one voice and a cello another, each shapes its own modes. It is the hum you coax from a wine glass and the note at which that glass shatters. It is why a bridge can sway itself apart in a steady wind, and why engineers hunt down the resonant modes of a skyscraper before an earthquake finds them first. Even a spacecraft is bolted to a shaker table and driven through its modes before launch to make sure nothing rings itself to pieces. Chladni's sand figures are just the friendliest face of a law that holds the physical world together. What began as grains dancing on a plate turns out to be a window onto one of the deepest ideas in physics, that vibrating things can only hold certain shapes, that those shapes are counted by whole numbers, and that resonance decides which one you get. Drop the sand, find the stillness, read the note. The same counting of modes runs from this plate all the way down to the quantum world, where the allowed shapes of a trapped wave become the allowed energies of an atom. It is the same song, played on very different instruments. And you don't need a laboratory to see it for yourself. Clamp a thin metal plate at its center, scatter it with salt or fine sand, and drive it from below with a small speaker and a tone generator. There's one in your phone right now. Sweep the frequency slowly, and you'll feel the exact moment the plate catches a mode. A sudden clear ringing, and the salt leaping up and racing into a figure as if it were alive. It is one of the very few places in physics where an invisible law becomes something you can watch snap into being on your own kitchen table. So sound was never really invisible. It just needed a surface to draw on. Give it a plate and some sand, and every pure tone reveals the figure it was carrying all along, a hidden geometry that was there in the note the whole time, waiting for a place to land. Everything you just watched is the real mathematics of vibrating plates, standing wave modes, solved straight from the physics and rendered in light. No effects, no invention, only the patterns the equations were always hiding. If you like finding structure inside something as simple as a sound, stay a while, there is so much more of it. This is Chaos Canvas. There's a lot more order and a lot more beautiful chaos hiding in the noise.